Hi students, this is Mr. Yao. Today we're going to talk about 1.6 where we will learn how to solve system equations by graphing. Since we're solving equations, then we have to talk about solutions. So what is a solution? A solution is a number that makes the equation or inequality true. Sometimes we may have more than one number that works, so that's why we can also say numbers that make the equations or inequality true. Now let's use that definition to find some solutions for each of the equations below. Example 1, x plus y equals 12. Well, unlike the equation we used to solve, now we have two different variables. So we're finding numbers that make this equation true, and we need to find two numbers. So basically, we're finding two numbers that add up to 12. So let's say we can have 6 plus 6, that's 12. Or we can have 12 plus 0, that's 12. Now let's involve some negative number. We can have a negative 1 and 13, that's 12. Or we can have, say, negative 24 and 36. That's also 12. Number 2, x minus y equals 12. So now we need two numbers that subtract to actually get 12. So we have 12 and 0. Again, let's involve some negative numbers. We can have 11 and negative 1. We can have 144 minus 132, that's 12. Or we can have 6 minus negative 6. That works. Example 3, example 4. Example 3, we need two numbers to multiply and get to 12. So 1 and 12, 2 and 6, negative 3, negative 4, or negative 2 and negative 6. And example 4, two numbers that divide get 12. We can have 12 and 1, 36 and 3, 144 and 12, or negative 24 and negative 2. So these are all solutions. And you may, of course, write some solutions that are completely different than the ones I gave you. And that would work as long as they would actually make the equation true. So for every single one of these equations, if I ask you to write, say, like 10 solutions, you will be able to write it. Or if I ask you to write 100 solutions, of course, I won't ask you to, but you can. Which basically means when you have two equations, well, when you have two variables, you may have more than one answer. So is the definition for a solution the same if you have two different variables in your equation, as opposed to only one variable? Well, the definition for solution is number that make the equation true. And we were basically just picking out two numbers that make the equation true. So yeah, it's still the same. And I have a typo, it should actually say yes, still the same. The definition did not change. Since we're learning about solving equations by graphing, let's learn a bit more about graphs. A graph is a representation of all the points that make the equation true. And the definition for solution is numbers that make the equation true. So you see they both make the equation true. Now that means the points and the numbers are kind of corresponding. The graph is a continuous string of solutions to the equation and is not, there's a typo again, is not just the discrete points we might use to sketch the graph. Here's what it means. We typically have points so that we can actually generate a graph. But it's not just these 2 points that actually would work. Not just these 2 points represent the solution. Any point on that line, it could be any of them, is going to be a solution for that line. That's why it's a continuous string, not just these points. It could be infinitely many points. Next, let's actually draw this graph. 3 is the intercept. The slope is negative 1 over 2. So down 1 over 2, down 1 over 2, down 1 over 2. We got some more points. And I can generate some more. Connect them, that's our line. And we need to write solutions for that line. The definition told us each point would be a solution because they make the equation true. So let's say we have this one, 0, 3. Or you can have more, let's say that one, 2, 2. Or you want the middle one, that's going to be 1, 2.5. Or if you say you want the negative one, that's going to be negative 4, 5. These all work. And again, you might write some points that are completely different than mine, which is fine. So here's the next question. How many solutions are there? And I'll tell you, it's not going to just be the points we draw. These points would work, these points would work on the bottom. Any point on that line would actually work. So we actually have infinitely many solutions. And that's why sometimes we draw arrow on both ends of the line to indicate it continues going and it never ends. It keeps on going. Since we're learning about system equations, let's define that system equation is a set of two or more equations that are solved together. Now, how can you tell what the solution to a system is from the graph? Since one line represents the solution for that, well, points on one line represents all the solutions, then points on the other line also represents all the solutions, then we're just finding the point that they share. So it is the point where the graphs or lines cross. So for example, if we have these two lines and these two equations, that's where they cross. So that will be their solution, which is 3, -1. And we typically write it as ordered pair to present solutions. If someone said the point 0, 2 is also a solution, what would you tell them? 0, 2 is right here. So that clearly is not a point where the two lines cross, but it is on one of the line. However, it is only on one of the lines, so it only makes one equation true. That's why it's not a solution for the system. Or what if someone said 0, 0 is a solution? Well, that actually is not on any of the line, not on either graph, so it wouldn't make any equation true. So of course that is not a solution for the system. Now that we have talked about what are solutions for the system and what are some non-solutions for the system, let's have a look at what kind of solutions we may get. For the first possibility, they only cross once, so one solution. For the second one, you may not be able to see it, but here's where the second line actually is. It is just on top of the first line. So they basically coincide. And in that case, you have infinitely many solutions because they're basically the same line. Now the last one, you can clearly see they're not crossing each other at all. They're parallel lines, which is why there's no solution. Now let's get to some examples. Example 5, we're going to graph each line. So first one, it is 4 as the y-intercept. Slope is 3/2, so up 3/2. Or you can backtrack to the other side, find more points. We can connect them. That's our first line. Now let's graph the second one, -2. That's the y-intercept. And oh, I actually graphed the first one wrong. It's actually at 4. So let's regraph that right here. That's where they will be. And now for the second one, the slope is -3/2. So down 3/2, or you can backtrack to get more points. Connect them. We are looking for where they cross each other. That's the point. We just need to write the coordinate 2, -2, 1. That's the solution for number 5. Now number 6. -1 as the intercept. Slope is 3/4, so up 3/4. You can also backtrack to the other side to find another point. That's the first line. Now the second line is at 1. And same thing, up 3/4, or backtrack to the other side to find more points. You can clearly see these two lines are parallel. They do not cross each other, so no solution. Number 7. Well, this time they're not in slope-intercept form. But we have learned in 1.4b about how to change these into slope-intercept form. Then in 1.5, we have reviewed about graphing. Now we're just doing both. So for example, equation 1, x plus 2y equals 4. We're going to solve for y, minus 3x on both sides. 2y equals -3x plus 4. Divide everything by 2. Y equals -3/2x plus 2. That's the first equation. Now I'm going to solve the second equation. Add x on both sides. So -2y equals x plus 4. Divide everything by -2. We got y equals -1/2 x minus 2. So graph the first one. The intercept is 2. Slope is -3/2. So down 3/2. down 3 over 2, or do the other way, the other side. As for the other one, it's negative 1 over 2, intercept that's negative 2, down 1 over 2, down 1 over 2, down 1 over 2, backtrack. So we got the other line right here. The first line is right here. You can clearly see here's the point where they cross, and that is going to be 4, negative 4. That's the solution to number 7. Number 8. Solve for y, so I'm going to move y to the other side. So y equals 3x plus 5, or 3 over 1x plus 5. The intercept is at 5. Up 3 over 1, or down 3 left 1. We can get more points. Connect them. Add my line right there for the first one. For the other one, it's x equals, and we in 1.5 we have reviewed if you only have one variable. If it's x equals, that means it is crossing the x-axis. If it's y equals, then it's crossing the y-axis. So in this case, it's crossing the x-axis at negative 3. Here's the point where they meet. That is going to be negative 3, comma, negative 4. That is the answer to number 8. Number 9, x equals 2. So here's the line. Because it's crossing the x-axis, x equals 2. Then the other one, y equals 1. So it's crossing the y-axis at 1. This is the point where they meet. The answer is 2, 1. Now number 10. First line, over 1. It's at 5, and down 3 over 1. 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 We have our line. I picked the wrong points. Here, 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 and here. There we go. Now we can graph our line. That's the first line. Second line, at negative 2, up 2 over 1. So up 2 over 1, and up 2 over 1, up 2 over 1, down 2 over 1. So we have our second line right there. You can kind of see where they cross each other, which is around there. And for that example, that is where you see weight. Graph is actually probably not the best method, because we kind of need to estimate where exactly that is, which is not the best way to actually find the point. But the point is actually going to be around right there, 3/2 is at 3/2 and 1. So as you can see, that point is not very clear to identify. So I will tell you the answer. That one is actually going to be so that point is actually going to be 7 over 5, and then comma 4 over 5. That's where it's actually going to be. And that is why you can see graphing may not always be the best method. For a question like that, we will learn other methods to solve it next time. That is everything for 1.6. Thank you.